Bismillahirrahmanirrahim. Allahumma salli ala Muhammadin wa ala ali Muhammad. Assalamu alaikum students. Today we will solve question number 9. In previous questions, we have learned how to find domain and range of a function. But here the question is find domain and range of an inverse function and also prove that f of f inverse of x is equals to f inverse of f of x. So basically we will learn about composition. The important point is that only one-to-one functions have inverses. Let's start. First, find the domain and range of the given function. As it is a linear function, so both its domain and range are set of real numbers. Now, for the inverse function, domain becomes range and range becomes domain. Now we have to prove that the composition of a function and its inverse is symmetrical. Means we get the same result. To prove this, we need to find inverse of the function. So let's recall the steps for an inverse function. First step is start with the original function, which is 4x negative 3. Or we can write it as y is equals to 4x negative 3 because f of x and y are equal. From here we can find the value of x, which is f inverse of y. Second step is solve for x. Now plug in the value of this x, which is f inverse of y. Step 3 is we replace this y with x because we need f inverse of x. So inverse of the function is x plus 3 over 4. Consider left hand side, which is f of f inverse of x. Write this f as it is. And write value of this f inverse of x, which is x plus 3 over 4. Consider this x plus 3 over 4 as x. It becomes f of x. Now go to f of x function and replace x with this new value. So it will be 4 into x plus 3 over 4 minus 3. 4 and 4 will cancel. This positive 3 and negative 3 will also cancel. And we are left with x. Named it as equation number 1. Now consider right hand side, which is f inverse of f of x. Use the same steps. Write this f inverse as it is. Use value of f of x, which is 4x negative 3. Again consider this 4x negative 3 as x. It becomes f inverse of x. In f inverse x function, change the x with this new x value. 4x negative 3 plus 3 divided by 4. This 4 and 4 will also cancel and we are left with x. named it as equation number 2. From equation number 1 and 2, left hand side and right hand sides are equal. The given function is in the form of fraction, and clearly we can see that when x is 5, denominator becomes 0, and we know that any number divided by 0 is undefined or it gives math errors. So x should not equals to 5. It means domain will be set of all real numbers except this 5. Now for range, we solve for x. By cross multiplying this x minus 5, we have y into x minus 5 equals to x. By rearranging terms, this x is common. So we are left with x into y minus 1 equals to 5y. By taking this y minus 1 to the other side, we get value for x. Now, this y should not equals to 1 because 1 minus 1 is 0. So range will be set of all real numbers except this one. Now for domain and range of inverse function, simply swap the domain and range of the given function. So domain of f inverse of x is r minus 1 and its range is r minus 5. We have to prove the same composition for this part also. First, find f inverse of x. Start with the original function, which is f of x is equals to x over x minus 5, or we can write it as y is equals to x over x minus 5 because f of x and y are equal. Now solve for x. By cross multiplying this x minus 5, we get y into x minus 5 equals to x. By rearranging terms, we have xy negative x is equals to 5y. After taking x as common, from here the value of x is 5y over y minus 1. Now put value of this x by using this equation. X is equals to f inverse of y. We need f inverse of x, so replace y with x. This is the required inverse function. Consider left hand side, write this f as it is and write value for this f inverse of x, which is 5x over x minus 1. Now consider this 5x over x minus 1 as x and it becomes f of x. Go to f of x function and replace x with the new value. So it becomes 5x over x minus 1 divided by 5x over x minus 1 minus 5. x minus 1 and x minus 1 will cancel. 5 is common in the denominator. And the answer of left hand side is x. Named it as equation number 1. Now consider right hand side. Write this f inverse as it is and use value of f of x, which is x over x minus 5. Consider it as x. Now it becomes f inverse of x. In f inverse x function, replace x with this new value. So 5 into x over x minus 5, x over x minus 5 minus 1. 5x over x minus 5. The LCM is x minus 5. X minus x plus 5. 5 and 5 will cancel and x is left. Named it as equation number 2. From equation number 1 and 2, left hand side is equals to right hand side. For domain, any real number except 1 will work. So domain will be set of all real numbers except 1. For range, we solve for x. And clearly, the value of y should not equals to 1. So range of the function is also set of real numbers excluding 1. Now for domain and range of inverse function, swap these. To prove this, we need inverse of the function. So by keeping all these steps in mind, we start with the original function, which is x plus 2 over x minus 1. Then we write this f of x as y because f of x and y are equal. In the next step, we solve for x. We already solved for x. So the value of x is 2 plus y over y minus 1. Now plug in the value of this x, which is f inverse of y. And in the last step, we replace y with x. Which is the required inverse. Consider left hand side, which is f of f inverse of x. Write f as it is and substitute value of inverse function, which is 2 plus x over x minus 1. Now consider it x or it's the input for f function. So replace x with this new input value. It becomes 2 plus x over x minus 1 plus 2 whole divided by 2 plus x over x minus 1 negative 1. For simplification, take LCM of numerator and denominator terms. LCM is x minus 1. To make the denominator same, multiplied with x minus 1. So it's 2 plus x plus 2x negative 2. And for denominator, LCM is same, which is x minus 1. X and x will cancel, and in the numerator 2 and negative 2 will cancel. So 3x over 3. The answer for left hand side is x. Now consider right hand side, which is f inverse of f of x. We write this f inverse as it is and substitute value of f function, which is x plus 2 over x minus 1. Again, it becomes the input or x value for f inverse function. So we replace x with this new value, which is 2 plus x plus 2 over x minus 1 whole divided by x plus 2 over x minus 1 minus 1. After simplification, we get the same result, that is x. So from 1 and 2, left hand side and right hand side are equal. Remember, if the function has a square root, we must make sure that the number inside the root is not negative. And the reason is a square root with negative number is no more real. For example, square root negative 1. It's not a real number, it's an imaginary number. That's why the restriction here is that this x plus 2 should greater than or equals to 0. So x should greater than equals to negative 2. It means our domain starts from negative 2 and the numbers that are greater than negative 2 means negative 1, 0, 1, so on up to infinity. So all these numbers are included in domain. As this negative 2 is included, so we use close brackets. Now for range, as this negative 2 is the first value, so put this negative 2 in the given function to get value of y. Negative 2 plus 2, that is 0. So range starts from 0 to positive infinity. And for inverse function, swap these. That is 0 to infinity. To prove this, we need value of inverse function. So we start with the original function and we write f of x as y because f of x and y are equal. And from here, the value of x is f inverse of y. After solving for x, plug in its value, which is f inverse of y, and then replace y with x to get the required inverse. Consider left hand side, which is f of f inverse of x. Write this f as it is and substitute value for this inverse function, which is x squared negative 2. Now consider this x squared negative 2 as x or input for this f function. Go to f function, which is x plus 2, and replace x with this new value. So we get this step. After further simplification, the answer is x and named it as equation number 1. Similarly, consider right hand side, which is f inverse of f of x. Write this f inverse as it is and substitute value of f of x, which is under root x plus 2. This time it becomes x. Now go to f inverse function, which is x squared negative 2, and replace this x with under root x plus 2. And then after further simplification, we get the same result. Named it as equation number 2. So from equation 1 and 2, we can say that left hand side and right hand side is equal. As the given function is a polynomial function, so every real value of x will work. Okay, let's check for some of the values of x. Now we substitute these values one by one in the given function. When x is 0, value of y is 6. When x is 1, the answer is 7. When x is 2, the answer is 10. When x is negative 1, answer is 7. It means whatever the value of x, there is an answer for y. Therefore, domain of the function is the set of all real numbers. Now for range, clearly we can see that there is no negative values in the range. And the smallest value is 6. So range will be the set consisting of 6 and all positive integers. Now for inverse function, swap these. Now we find inverse of the function by writing the given function as it is, and then we write this f of x as y because f of x and y are equal. And from here, x is f inverse of y. And then we solve for x and plug in value of x, which is f inverse of y. And finally, replace y with x to get required inverse. Consider left hand side, which is f of f inverse of x. Write this f as it is and substitute value of this inverse function, which is under root x minus 6. Now consider this x minus 6 as x, or it is the input for f function. F function is this one. So replace x with this new value, which is under root x minus 6. And then after further simplification, we get x as answer. Now for right hand side, follow the same steps. Write this f inverse as it is and substitute value of f of x. Now consider this x square plus 6 as x, or it is the input for f inverse function. F inverse function is under root x minus 6. So replace this x with x square plus 6 to get this step, and after simplification we get the same result. So from equation number 1 and 2, left hand side is equals to right hand side. In this function, the value of x should not equals to negative 4, because at negative 4 the function becomes undefined. So domain of the function is set of all real numbers except this negative 4. Now for range of the function, we solve for x. Given function is 2x negative 1 over x plus 4. By cross multiplying this x plus 4, after rearranging terms, we get xy negative 2x is equals to negative 1 negative 4y. So clearly the value of y should not equals to 2. So range will be set of all real numbers subtracting 2. For inverse function, swap these. Now we find inverse of the function. For this, start with the original function and write this f of x as y, because f of x and y are equal. From here, value of x is f inverse of y. And we have already solved for x. So simply plug in value of x, which is f inverse of y. Replace y with x to get inverse of the function. Now consider left hand side, which is f of f inverse of x. Write this f as it is and substitute value for this f inverse of x. Now consider it as x, or input for f function. F function is 2x negative 1 over x plus 4. And then replace x with this new value. And after simplification, we get x as an answer for left hand side. Similarly, for right hand side, write this f inverse as it is and substitute value of f of x. Now consider it as x for f inverse function, which is negative 1 negative 4x over x minus 2, and replace x with this new value. After simplification, we get the same result, that is x. Hope this video will be helpful for you. Thank you for watching.